In this video, I am going to solve this differential equation that has constant coefficients, and the characteristic equation has complex roots, and the differential equation is y double prime plus 25y is equal to 0 with initial conditions y of pi over 5 is equal to 3 and y prime of pi over 5 is equal to 10. So let's go ahead and solve the problem, and we will make the usual assumption that our solution has this format: y is equal to e to the power rt, that leads to y prime is equal to r times e to the power rt, and y double prime is equal to r square times e to the power rt. Now we can go ahead and substitute these values and try to simplify things. So it's going to be r square plus 25 times e to the power rt is equal to 0. So this product of two factors is equal to 0, but e to the power rt is not equal to 0 because it's an exponential function. Therefore, the other one must be equal to 0. And if I set that equal to 0, I get r square plus 25 is equal to 0, or r square is equal to negative 25, or r square is equal to, actually make it r is equal to square root of negative 25, right? Which I could simplify further. That's going to give me r is equal to square root of negative 1 times square root of 25, or r is equal to plus or minus I times square root of 5, which is basically 5. So that's your solution. So your r1 is equal to 5i, and your r2 is equal to negative 5i. Now my solution is going to be y1 is equal to e to the power 5i, and my y2 is going to be e to the power negative 5i. So remember, here you don't have a complex number of the form a plus I times b. A is 0, of course, right? So you have the imaginary part, no real part. And this means my general solution could be y of t. Actually, I missed a t here. So my general solution is going to be y of t is equal to c1 times y1. Okay. Let's use a different value. k1 times y1 plus k2 times y2, which basically is going to give you y of t is equal to k1 times e to the power I times 5t plus k2 times e to the power negative I times 5t. All right. Now we could go ahead and make the following assumption. We could set it. Actually, let me just jump into another thing. So this is gonna be y of t is equal to k1 times e to the power I times 5t is gonna be cosine of 5t plus I sine of 5t, right? Plus k2 times cosine of 5t minus I times sine of 5t, which is just the Euler's formula. Now, by adjusting the values of k, if we make the assumption that k1 is equal to k2 is equal to 1/2, then we get u of t is equal to cosine of 5t. Now, if I make the assumption that k1 is equal to k2 is equal to 1/2i, then I will get v of t is equal to sine of 5t. And this is basically using the fact that a linear combination of two solutions is also a solution to the differential equation, and we are using the fact that k1 and k2 is we could select specific values to come up with a solution that is real as opposed to having imaginary part to it. Now my general solution is going to be this, so let's go ahead and write it out here. Y of t is equal to c1 times cosine of 5t plus c2 times sine of 5t. Okay, so y prime of t is gonna be equal to negative 5 c1 times sine of 5t, right, plus 5 c2 times cosine of 5t. So I could take this y of t and y prime of t and use these values respectively, y of pi over 5 and y prime of pi over 5. So y of pi over 5 is equal to 3. So in this one, if I plug in pi over 5 is equal to 3, so c1 times cosine of 5 times pi over 5 is going to be just pi, right? Plus c2 times sine of 5 pi, 5 times t is pi over 5. So that's going to also give you pi. Of course, sine of pi is 0. So, and cosine of pi is 1, right? So that gives me c1 is equal to 3. Similarly, when I take the derivative and I find this expression, and y prime of pi over 5 is 10, so I'm going to put 10 here. I'm plugging into this value or this initial condition, and that gives me negative 5 c1 times sine of 5 times pi over 5, so it's going to be sine of just pi, right, plus 5 times c2 times cosine of 5 times pi over 5 is just pi. And this, of course, is going to go to 0 because sine of pi is 0, right? So that gives you, and cosine of pi is 1, so that gives you 5 c2 is equal to 10, and your c2 is equal to 2. So you found the constants that goes with the given initial conditions. C1 is equal to 3 and C2 is equal to 2. So your final general solution is going to be, for these given conditions, is going to be equal to C1 3 cosine of 5t, let's put parentheses around it, plus 2 sine of 5t. Okay, so this should be your solution to the given differential equation with the conditions, initial conditions. I hope that this discussion was helpful. Thank you very much.